Okay. Greetings to you all. I'm so excited to be your co-host for today, the first ever virtual Africa Science Buskers Festival, the fourth and the biggest one ever to be held since its initiation in 2016. So my name is Molin Simanga, and I'm going to be co-hosting with Ashley Nyaradzai Chizema. So I would want to extend our deepest apologies for the technical difficulties that happened in the first session. It was due to internet instability, and we are very sorry for that. Would want to extend our unwavering gratitude to all the people who have been working behind the scenes to make this event a success. All the people who devoted their time to make this event what it is today. Would also want to clap hands for all the group of students who have been working in different WhatsApp platforms, facilitating and sharing information concerning the Africa Science Baskers Festival. Such gestures should not go unnoticed at all, and we really appreciate you for that. Well done, guys. So this time I'm going to be leaving it to my co-host, Ashley Nyara Zaichizema. The floor is yours now.
Thank you, Smiley. I'd like to introduce a special man for our next session. With a Bachelor of Science Honours degree in Physics, a postgraduate diploma in Electrical Engineering, and another postgraduate diploma in Business Management, Dan Matsapola is a wonderful work experience in the global space industry. His incredible expertise about satellites extends to human use, the benefits of such technology, from tracking low Earth orbiting satellites to promoting the use of Earth observation, supporting sustainability development in Africa.
Good afternoon. Can you hear me? Okay, I hope you can see my presentation slide. So, thank you for the wonderful introduction. I'm operating under the assumption that you can hear me and you can see my presentation. So, as introduced, my name is Dan Matsapola. I'm the Science Engagement Manager at the South African National Space Agency. And it's my pleasure to be invited to present and share the power of space science and technology to unlock massive socio-economic benefits for society. My presentation outline would focus on the role of space science and technology in the innovation cycle, the brief history of South Africa space science activities, and then I'll tell you a little bit about SANSA and the three major challenges that we are facing today in the world. Our opportunities in the continent of Africa, and then I'll look a little bit at the career opportunities in space science and technology, focused on science communication, which is what I do, and then we'll take questions. By now, you may know that South Africa has been involved in the space race from the very beginning of the space race, supporting the early launches, including the launches that put men on the moon in 1969. So we've been around this game. We have had over 50 years of involvement in the space industry, and we have facilities that are very old and mature that have good reputations around the world as facilities to partner with. We've been part of many global networks around the world. This is just one example, being this French network that we've been a part of since the mid-1980s. We've also been part of the American network, the Landsat network, since the very early days in the 1970s. And so we today are playing in the space. As I'm talking to you today, we are turning 10 years old as the space agency. And South Africa has been a spacefaring nation for the last 21 years, since 1999, when SANSA was launched by the University of Stellenbosch. And so from that history, there was a need to bring together all of these various competencies within the country into one body, to speak with a common voice as a country to the rest of the world, and to coordinate all the space activities within the country. And that's when the SANSA Act of 2008 was put together. And today we have the South African National Space Agency, with a vision to have an integrated national space capability that responds to socio-economic challenges in Africa by 2030. And to provide leadership in unlocking the potential of space for the advancement and benefit of humanity is our mission, our reason for existence, to unlock the potential of space. Our motto is in service of humanity. So we are arranged around 4 programs at the moment. The National Space Program is now renamed Satellite Engineering, and this is the one that coordinates the development of satellite missions that are responsive to the needs of society, particularly the users of those technologies and the products and the services developed and derived from the use of outer space. And we have the Space Operations Division that deals with supporting launches to outer space, launches that may be coming from many other parts of the world. In fact, it evolved out of the early mission by NASA to have a tracking station in the Southern Hemisphere located in South Africa. And we have, it used to be called the CSIR Satellite Applications Center. It's in Hartbeespoort, South Africa. That's where we have a lot of those antennas that are shaped like the dish on which you eat your food. So we also have one of the oldest programs, being the Space Science Program in Hermanus, that deals with the near-Earth space environment and the research that is done there, and Space Weather Forecasting Center, which is the only one we have in the continent of Africa. And increasingly, it's becoming very strategic for the aviation community with the kind of work that is happening in that magnetically quiet environment in Hermanus, near the ocean. And then, of course, we have the Earth Observation Division, which is where I am from, in Pretoria, that deals with the use of satellites that carry powerful cameras and sensors on board that can detect changes on the surface of the Earth, in the atmosphere, and in our oceans. So we are moving and growing now into a bigger playing space and focusing beyond the boundaries of South Africa, broadening our focus into the continent of Africa. And our satellite footprint, of course, is over Southern Africa, but we are bringing to bear the full might of space science and technology to support the African Agenda 2063, where we want to leverage this unique window of opportunity that is open, where we have a 1.3 billion population in 54 countries, and the youngest population on the planet. So we have an opportunity to use the power of space science and technology to bear on the education of our young people, and to bring more scientists into our communities, so that we can migrate Africa's reliance on its rich minerals and migrate Africa towards the knowledge economy, which is truly today's signature economy globally. The fact that we are having this virtual platform is testimony, it bears testimony to the fact that we need to embrace digital technologies. We need to embrace technologies of all types, including space science and technologies, in doing farming that we are known for, in bringing those minerals from underground, but also in mining a very rare mineral called the human intellect, bringing to the surface what lies within man. This is my favorite part. And as manager of science engagement at the Space Agency, I deal a lot with this. We have satellites in Earth orbit, from low Earth orbiting satellites, which is where all of South Africa's satellites were destined to. So space begins at 100-kilometer altitude, which is known as the Kármán line, but extends outwardly infinitely. There is no limit to where space ends, but we know where it starts. So low Earth orbit would be where many of those satellites that you see in my slide right now, that give us terabytes of Earth observation data, which we convert and transform into information that a user can use through their mobile phone, through their laptop computers, without even knowing the science behind it. That's ultimately where we need to be as the Earth observation community globally. And increasingly, we are storing this data in the cloud. And as you can see, cloud-based computing becomes one of the key components. So we're encouraging more young people in the continent of Africa to embrace digital technologies and to actually take up science, mathematics in schools, including geography, of course, which we need to particularly use these data sets and integrate them with other socio-economic data that we derive through things like sensors and other platforms. So as we transform these data sets into information, we use the technology, of course, of space science and technology, where we have orbiting satellites. And there is an example of an image acquisition coverage from the center of the circle, that is the satellite ground station SANSA has in Hartbeespoort. That's where those antennas on the right are. And it extends for about 2,500 kilometers from the center, which is where we track the satellites coming down over the horizon due to the curvature of the Earth. From as far, we pick up the signals from as far north as Bujumbura, Burundi, which is about 5 degrees south of the equator. And we know Kenya is right by the equator there. So we track satellites from different parts of the world. We have arrangements with other space agencies and other commercial service providers, satellite providers. So we archive those satellite data sets since the 1970s. So we are sitting on a very strategic asset called the Satellite Data Archive, which we are increasingly exploring newer methods to exploit and serve it without the user having to invest very heavily in the infrastructure needed to exploit that. More like my email that I currently am accessing through the cloud. And I don't have storage facilities in my house, nor is my phone attached to any heavy duty storage facilities and processing facilities. But I can access my emails on the fly from wherever I am in the world because of the cloud infrastructure. Just to give you an idea of the value chain of space, and in particular focusing on the Earth observation via satellite, it may look like this is a linear process according to the design of this poster, which we use to support education, science, technology, engineering, and mathematics education. You will notice from this that the major source of supply in the remote sensing process is the sun. And most of our satellite sensors are passive sensors, which means they depend on the illumination from the sun that they can measure the reflected solar radiation through their sensors. And that measuring of solar radiation helps the satellite sensor to characterize the actual phenomena on the ground that interacted with that light. So, and then it communicates it down to the satellite ground station, where it will be processed into the format that you will see on such public domain platforms as Google Earth and even Google Maps on your phone, and many other platforms that are open that you don't have to pay for. So space science and technology is no longer the exclusive preserve of very rich countries, but it is the easily accessible technology platform that enables development of business intelligence. It helps even the African household to understand the dynamics of markets, because information has become converged into these devices that we carry around. So my job at the space agency is to communicate this broad science. The satellite ground station is where I began my career, tracking satellites for the South African government, and then passing them on to the analysts and the remote sensing scientists, who actually use very sophisticated software platforms to process that information and convert it into analysis ready data that can be merged and combined with other data sets, like where people are, like petrol stations, like other socio-economic data sets, that then becomes a very rich source of information that can tell us a story about the development and the changes that are happening on the land, in the atmosphere, and in our oceans. As you know, South Africa is surrounded by rich ocean, and we are serving an entire community, an ecosystem of government, its agencies, and even private sector, including the banking sector. So you are withdrawing money from an ATM, you don't even recognize that that actually transaction is enabled through a network that is interconnected with satellite technology and many other such backhaul technologies in the background that you don't, as the user, ever get to see. We also using the platform of space to monitor our oceans. This particular project is called Operation Pakisa. Pakisa meaning fast track. So we want to fast track the blue oceans economy and monitor our oceans. We're sitting with around 3,200 kilometers of coastline from Durban all the way around to the west coast. So we are using, if you were to bring ships to monitor that ocean environment, they would take much longer. And by the time they finish the monitoring, you will basically take much longer, and you will not derive instantaneous information intelligence that allows you to make decisions that are rapid and allow you to react. If there is any illegal fishing in our waters that should benefit South Africans and South African businesses, then you are able, the authorities and the port authorities, maritime authorities are able to react timeously. So space science and technology is truly a very strategic field of science that we feel we must invest in, not just as South Africa, but increasingly the continent of Africa. The African Union has already approved a strategy that is going to be implemented. It's being implemented Africa-wide. As we know, the African Space Program is being hosted in Egypt, and I know that Zimbabwe has its own space agency, and many other countries in the continent are embracing space as a strategic field of investment that will help to bring us as a meaningful player as the continent of Africa into this knowledge economy. So we are using satellites to also study climate change. I alluded earlier to the three major problems that are facing the world today. We are sitting with disaster management, and we are now in COVID-19, which is a major disaster that has materialized. So disaster risk reduction, building adaptation strategies to these disruptive forces, building resilience in the African economies, particularly the African household, which is really where the resilience needs to be built. So we need African children, youth, to embrace science and its role in keeping our stomachs fed and our health intact. And of course, developing mitigation strategies. So disaster management is one of the major problems we are facing today. And we know that there's also climate change, and the temperatures are increasing, the water level is rising, ice is melting, and this is causing havoc with food production. It is causing havoc with our farmers, and we need to better prepare using scientifically sound information derived from science missions and orbiting satellites to inform those adaptation strategies for our agricultural production, food security. Okay, and then of course, the biggest agenda, development agenda, is at the United Nations level, which is number 3. Of course, it's Sustainable Development Goals. And now that brings me to my favorite goal, being goal 4. Not that other goals are not important. All the other goals are as important as any other goal, but I chose goal 4, which aligns very well with the work that my unit is doing to stimulate thinking. Goal 4 is about quality education, and I'm glad to acknowledge that you provide this platform for us to engage with African youth, to share our insights, and to stimulate them to think like we have never thought before. The thinking statistics are very, very scary in the world. If you go by what people like Dr. Ken McFarland have said, that in the whole world, only 2% of the population thinks, 3% think that they think, 95% would rather die than think. And as you know, Albert Einstein said, education is not merely the learning of facts, but the training of the mind to think. So thinking is very, very strategic, and it's not something we should relegate to the psychologists and the psychiatrists. All human beings carry with them a great gift called the mind, and it needs to be developed. So we use space science and technology to stimulate thinking in our young people, to think beyond ordinary appearances that we are surrounded by. An earth that doesn't look like it is moving when you look at it with the naked eye, and that doesn't even look like a ball or a sphere. Yet we know that the earth is actually a sphere that is rotating around its axis, as it is at the same time orbiting around the sun, taking exactly 365.25 days to complete one orbit around the sun. So we have been inspired by this movement of the earth and the discovery of the rotation of the earth around its axis to come up with the principles that have led us to the development of man-made satellites, because the earth itself is a natural satellite, and as are all the other 8 planets that are orbiting around the sun. So this is where we have interfaces with our astronomy friends, because we are really cousins sharing the same platform called outer space, where we put satellites and they put some spacecraft, including telescopes that are out there in outer space, observing the vastness of the universe. So we support STEM education for the knowledge economy, and we do these exercises in the classrooms. I'll show you some of the activities that we do as science communicators. And we promote the innovative use of space science and technology by the youth. Like I said, gone are the days when space was only the exclusive preserve of major rich countries with deep pockets. Today, the poorest country on earth has ambitions, and some have actually become spacefaring nations. High schools are building satellites. We are working with engineering companies in South Africa that are building very small chips that are put on satellites, and we are using those platforms to bring consciousness into our young people of such phenomena as humidity and temperature, and making measurements, getting our young people accustomed to taking measurements, documenting, observing, which are the hallmark characteristics of a scientist. We observe and document. We think as scientists, and we question everything. And that's where the innovations come from, questioning everything that we come across. We develop awareness of career opportunities, and today I'm focusing on science communication as a career. I've been in this career for the last 12 years. It's very rewarding. So I left the hardcore science where I was tracking satellites, and I've learned and studied further into the field of remote sensing and GIS. And now I decided that I will make more meaningful impact if I communicate the science. To whom? We communicate to a very diverse audience, including young people, students at academic institutions, tertiary institutions, and we're talking to teachers. We work with journalists who are helping us send the message across, and we're talking to indigenous knowledge holders. This is true to Africa, but even beyond the continent of Africa. Indigenous knowledge holders who have old ways of doing things that have worked for millennia, for as long as their societies have been in existence. And embracing new technologies can be a bit of a challenge, especially when we think we scientists know it all, and we use the deficit model of communicating science, where we think we are the experts and we tell them. But through engagement, we actually realize that we actually need to learn from our audiences. So we work with science interpreters. We have a network of more than 34 science centers in South Africa. And increasingly, we are working with science centers across the continent. We have recently done a virtual tour of the satellite ground station with Ken Munjero, my good friend from Kenya, where we had children from all over the world through his platform to actually get exposure to the field of space science and technology. All right, and we have support from the very top. As you can see on the right there, the man sitting there with two journalists is the CEO of the space agency, Dr. Val Munsami, who is at the forefront of leading this service of the space industry to humanity. And if you have been watching the media, you will see that he has been spearheading a very ambitious project where we want to grow. We've set our space program on a massive growth trajectory to actually go beyond the small focus areas that we've been involved in, and to embrace the fullness of the space value chain, and to add those elements that have been missing in our business, including telecommunications, including global navigation satellite systems, with a particular focus on the continent of Africa through such initiatives as an augmentation system. And on the left there, you will see the only space weather regional warning center, which is in Hermanus, Western Cape. And my good colleague there taking visitors on site on the good work that they do, studying the sun 24 hours a day, and being able to provide those early warnings to those industries that are susceptible to disruptions that are caused by activity on the sun as it goes through an 11-year solar cycle from solar minimum to solar maximum. Okay, so we also go out to schools using the mobile laboratory, where we do experiments that support curricular activities in the sciences. We also have, of course, very hands-on activities at our science centers. We have a science center in Hermanus, and we're contemplating building another one for the northern provinces here in the Gauteng province. And we are supporting science clubs, working with the Department of Science and Innovation, who is really the shareholder of the space agency, and the Department of Education in the various provinces, reaching out to those young people in rural areas particularly, whom are not exposed to space facilities, and we are increasingly creating awareness and unearthing that local raw talent that is lying dormant within the young Africans, and we are exposing them to opportunities that will allow them to see themselves as future captains of industry. I myself come from a rural area. You know you are there because you see donkey, you see gravel roads. It's only in the last 10 years that we have tarred roads, but we grew up in gravel roads. And so we bring space into the classroom with hands-on activities. This is a satellite simulation software that we use. It's used by technicians in the ground station to actually track and monitor satellites as they come over our ground station. And they are also useful to help with teaching such concepts as time zones and satellite orbits. And of course, we do very practical physical measurements. We go to schools and we have the children use a smartphone to take GPS coordinates, and then we plot them onto GIS software, and then we can do very basic calculations. And that which we do in the school, we encourage them to do in their African households and in the agricultural fields in their communities to support the use of space in food security, in disaster management, in doing very basic analysis that space allows us to do. And of course, these are our normal mass participation programs that we are unable to do because of COVID-related risks. Science festivals. I'm glad this science festival is 4 years old. And of course, it's embracing technology, with this 2020 edition being the first virtual one. So we invite you also to visit our facility. I know Knowledge, we have spoken about that. We have people from all over the world. You will see former NASA Jim Adams in the picture there, where we were hosting the multi-wavelength astronomy project, finding ways to create very impactful science communication mechanisms to reach out to communities. So we are hosting groups of young people from schools in rural areas, and we provide this as a public good service. We don't charge a cent for this service. And so we look forward to the partnerships that are very important in reaching out to the African diaspora. Like I said, Africa has the youngest population, and we need to catch their children young. I got introduced to space science and technology at the age of 23. I was doing my honors degree at the University of the North. Today it's called the University of Limpopo. And I didn't know anything about space, nor the fact that there are any space-related activities in South Africa. That South Africa supported the Apollo landing on the moon in 1969, I had no idea, because I was based in the rural parts of South Africa. And South Africa, you know, it comes from a very ugly past. And so it used to be perceived that these kind of fields were only preserved for the privileged. Today, it is my duty to make sure that I can talk to 10-year-olds, 12-year-olds, and growing up to all the adults that may still be locked into the old paradigms that no, space is only for those people who have money, who can actually live nearer to the facilities themselves. Okay? And COVID-19 has forced us, which is a good thing, forced us to develop our virtual science engagement. And this science festival, the African Science Buskers Festival, is one of these platforms we look forward to using to engage with a more increasing African and global user base, to form part of the many voices in the space industry that seek to penetrate various application domains, including farming, where farmers are saying we've traditionally done farming this way. And we are showing them that users, farmers in Europe and other parts of the world are now harvesting yields of around 7 tons per hectare because of infusing space technologies into their business processes. And it has been shown that even during COVID-19, for governments and those aid and service-based organizations to reach users with those relief mechanisms, they need the information, they need the intelligence. During disaster management, and I said that disasters are one of the there is an entire Sendai framework for disaster risk reduction, which is a key protocol for how countries should actually prepare themselves and organize themselves for disaster when they hit. So, to the young people of our continent, I am saying space is no longer a closed field, it is open for business. What you need to do to prepare yourself is to actually study mathematics, study physical science, study geography, study the computer systems, embrace these sciences and these engineering disciplines, and start by becoming conscious that you are being prepared for an economy that doesn't yet exist but is progressively unfolding. As you can see, global forces are disrupting the way we are doing business, the way we are creating value, the way that we are even creating jobs. We don't know whether the kind of jobs that are going to come in the next 10 years, what they will look like. We can see the trends with the fourth industrial revolution, but they are changing so fast. So we need versatile thinkers, we need people that can think outside the box, and we need solution providers. No longer do we need, industries are no longer in need of people that just want to get a job and perform a function. Increasingly, many of the roles are performed by robots, and we need to prepare our young people to embrace programming, robotics, and many other fourth industrial revolution technologies, Internet of Things. In the space industry, we say the very things that we say Internet of Things are located somewhere. You know, my refrigerator will be talking to my cell phone and talking to my infrared gate motor and garage motor that is operated and all converged onto my mobile smartphone while I'm sitting in Malaysia or in the Bahamas on holiday. I will be changing the temperature of my refrigerator. I will be switching lights on and off, sitting wherever I am. So I noticed that I'm at the 37-minute mark, and I would like to leave you with this slide that says space is open for business. And when you visit our facility, this is where I started my first job, not necessarily at this facility, but using those dishes to track and communicate with low Earth orbiting satellites. In those early days, I didn't even know that I could use space science and technology to monitor changes at my great-grandparents' farm in Limpopo province. Today, we have these tools that we can do that with. And ladies and gentlemen, we used to say hands-on activities, but COVID has exposed us to the risk of human contact. So now we are saying mind-on activity. Let us convert back and revert back to the primary mission of education, being the training of the mind to think. I thank you for the opportunity and will take questions if there are any.
Thank you so much, Mr. Dan Matsapola. We really appreciate your presentation. And yes, like you said, as far as the space sector is concerned, it's a race. And we as Africans, we need to run the race with endurance. Thank you so much for that. So right now we are leaving this time to questions, for questions to the audience. So I'm going to read the first question from Sharon Ramosi. Does the SANSA have space programs for students outside South Africa? And if so, which are some of the programs?
Okay, thank you very much for that question. Yes, we do have programs that are open for students that come from outside South Africa. The space science program that is based in Hermanus, Western Cape province, has taken on students from across the continent of Africa, and increasingly is taking on more because we need those skill sets from the continent that can be brought to bear on this field of space science and technology. And even outside of SANSA, of course, we know that the square kilometer array, Africa is hosting the largest part. And we know that a lot of countries in the continent of Africa, including Ghana and Botswana and many, many others, are partner countries in this. So space science and technology is set to transition Africa into a knowledge economy.
Okay, thank you so much. Okay, any questions from the audience? And then this is Azikia Zain. She's asking, I am asking you as a student, Mr. Dan, what is the most important thing when I'll do my research about space? Because it's really hard. So how do I start? So basically, she needs to know the first step you need to do when researching about space.
Okay, if you are researching about space, and I as a student, I assume you are referring to what research areas you can get involved in. I
Yeah.
would advise that try and find a connection between space as a platform and a technology and an emerging industry, as well its linkage to your everyday usage. Because gone are the days when you were just doing research in the hope that someday, somewhere, someone will open an opportunity for you. Increasingly, we are creating platforms for ordinary citizens to become users of space technology. Space is in your cell phone, GPS is enabled, in-car navigation systems are becoming common in many of the cars, including taxis and public transport. So if the question was referring to which research areas in space, they are broadly telecommunications, which we are using partly now to communicate through the airwaves. We are talking about Earth observation, which uses satellite technologies. Google Earth will be one of the popular ones that people are accustomed to, showing the images taken by satellites already in analysis ready mode. Then you could be talking about global navigation satellite systems, which I talked about, and increasingly navigating around. Of course, that is one of the applications.
Thank you so much, Mr. Dan. Any question? I do have a question though. You mentioned something about the space industry having been behind in some of the African countries. So, what could be the reason why some African countries are still behind as far as the space sector is concerned? And what are the solutions? What can we really do in order to catch up?
Space used to be very expensive, Smolly. It used to be very expensive, and it takes time sometimes for people to embrace that actually changes have happened since the space race between the two superpowers, Russia and the US. Today, in South Africa, we are building satellites the size of a loaf of bread. We are building CubeSats. There is an entire CubeSat revolution, and I'm aware that Zimbabwe is working on its own CubeSat mission. Knowledge and I have exchanged some information in that respect. Today, high schools are conceptualizing satellite missions and experimenting. And so we We need to know that changes have happened. We need to know that satellite systems are increasingly becoming smaller. We need to know that as Africa, we must embrace the use of space technologies in our everyday life experiences and increasingly make the connection beyond just us consuming the products that are developed elsewhere, but coming into the innovation space as creators of products and services that the rest of the world needs. We need to move away from just research for the sake of research and
Yeah,
get
true,
into
true.
research towards innovating.
Very true. Yeah, okay. Any questions from the audience? Any questions from the audience? This is from Manfred Mauba. Do you have any training plan for space science education?
At the Space Agency, I look after human capital development. Like I said, I left the hardcore sciences and the engineering field, and I said, I'm going to unlock opportunities. I'm going to focus on coming up with strategies for reaching out more young people like myself who may not even be aware. So space science education is critical. It's critical, and we are embracing our role and our partnership with the education sector, particularly basic education, which has curriculum elements that are space focused. In geography, we know about remote sensing and GIS. In planet Earth and beyond, in the natural science stream. And we also know that increasingly more universities are specializing. The latest satellite that went up into space in 2018 on December 27th, it's a CubeSat the size of a loaf of bread.
Oh,
That satellite was built by students at the Cape Peninsula University of Technology.
okay.
And that program has been producing engineers, many of whom come from the continent of Africa. So
Wow, nice.
education is key.
Yeah, very true, very true. Thank you so much for clarifying on that one. This is from Nyara Jomotiti. What major project is the SANSA currently working on? That's a very good question, Nyara Jo. I'm so curious to know about it as well.
I don't know if you've been watching the media lately, and I did allude to it. It's something that it's unfolding, and it's the most exciting project that we are working on. Firstly, we defocused our attention from South Africa. You know, we are the South African National Space Agency. We are now going into the continent of Africa to bring the full might of space science and technology to bear on Agenda 2063, the Africa we want. I'll be 87 years old in 2063. So we are now leveraging investments that are coming our way. And the SANSA CEO is in the media currently talking about this 4.5 billion rand investment building the next generation satellites that will be addressing uniquely African challenges. In the 54
Wow.
countries that are in Africa, you've seen that there are more than 30 of them that are sitting with the coastline. And we are talking oceans economy, we are talking knowledge-based economy, we are talking educating the young people of the continent of Africa. So space science education becomes critical, and human capital is a key part of our strategy to unlock value in the continent.
That's very true. That's very true. Okay, thank you so much for clarifying. This is from Malifia Finda. I have some question. What do you think about students who think that learning is not important? Yeah, yeah, very good question, Finda.
Uh, Education remains the critical. Nelson Mandela, our statesman, our founding father of this rainbow nation, said, no nation will ever develop without its citizens getting education. He said,
Very true.
education is the most powerful weapon we can use to
To
change the
change the
world.
world.
And in South Africa, I am a key advocate of education beyond just the academic education, but education that is embracing the doing rather than the knowing. We have a missing link between knowing and doing. And that is why we become reliant on product developed somewhere else. We need to do experiment, experiment, experiment is the hallmark of science.
Okay. Any question from the audience? And while still on that question, I would also want you to clarify. Right now the youth believe that it's better to be a hustler than to be sitting in the classroom learning. And then they do believe that right now there are so many ways to be making money. You can do forex trading. It does not require any qualification. You can be selling some things. You can start your own company without any education. What do you have to say about that misconception? People say that you don't need to go to school in order for you to make money, to be rich. What do you need to clarify on that one?
Look, young people observe trends and they make conclusions based on what they observe.
Yeah.
We have seen also a proliferation of billionaires that have very little academic education background. What I want to advise young people is the importance of this academic training, because it forms a very strong foundation. Particularly, I'm a scientist. The analytical skills that you get from a Bachelor of Science degree helps, because I've seen those people who ride a wave and they leverage these get rich quick schemes, but they cannot sustain it because something is missing. Basic analytical skills are missing, and they end up back to where they were prior to that windfall, and then they regret why they never built a strong foundation before they built this empire that needs to rest on that foundation. Education is critical, both the academic and the outside the classroom education that is increasingly evident. It's also critical. So academia is embracing experiential learning as well. We are noticing that as well. That's why today academia is even giving credits to prior learning that is not necessarily classroom based.
All right. Thank you so much, Dr. Matsapola. Thank you so much. That was really a splendid and profound presentation, and I was really inspired. Thank you to all the students who joined in.
It's actually Mr.